The AIM-7M all-weather missile system was developed for the Navy and Air Force air superiority fighters to defend against enemy aircraft. General Dynamics is second source manufacturer of Sparrow. The monopulse receiver of the AIM-7M offers improved performance against maneuvering targets in the presence of countermeasures. The surface-to-air version, RIM-7M, also known as Sea Sparrow, is used in a self-defense role with the U.S. Navy and its allies. RAM, the rolling airframe missile, is the basis for a new generation quick-reaction self-defense system designed to effectively counter the anti-missile threat. By applying the rolling airframe principle, guidance, signal processing, and control channel requirements are substantially reduced. This results in fewer components, lighter weight, smaller size, increased reliability, and lower cost of this 5-inch diameter missile. The use of passive radio frequency and infrared guidance provides for autonomous in-flight operation, allowing simultaneous target engagements and the high rate of fire necessary to assure ship survivability during saturation attacks. When the missile is launched in the direction of the target, it maintains that direction until the passive RF guidance signals call for a course correction. RF guidance signals also point the IR seeker toward the target until there is sufficient IR signal to acquire the target in terminal homing.
Phalanx, the Navy's close-in self-defense weapon, a totally autonomous standalone system. Phalanx is a weapon system designed to handle close-in threats, the need for which has been dramatically illustrated by the increased use of anti-ship missiles against naval targets. Its automatic search, detect, track, and fire features makes it an autonomous weapon system, with no dependency upon other ship systems. Phalanx is an important layer of the layered defense concept. Along with a high fire rate 20mm Gatling gun, Phalanx lethality is enhanced by a unique gunfire control technology called closed-loop spotting. By tracking both the target and the projectile in the vicinity of the target, an error measurement is obtained. This error is automatically corrected to align the projectile with the target to provide a kill. These projectiles were designed and developed especially for the Phalanx gun and consist of sub-caliber, spin-stabilized, heavy metal penetrator rounds that provide maximum lethality. Phalanx makes use of target analysis data during an engagement to make a kill determination. After verification of a kill, the system will resume search for new targets. In firings against tow targets, drones, both subsonic and supersonic, and bombs, the accuracy of Phalanx was continuously proven. Rapid reaction time from detection to engagement was confirmed by tests in which target drones were launched at Phalanx in rapid succession. As a result, multiple target reaction time was proven effective.
The Tomahawk family of cruise missiles, developed to provide a versatile weapon for America's defense. Tomahawk's features: it is small, low-flying, far-ranging, evasive, reliable, and accurate. The Navy's sea-launched cruise missile, Slickum, was the first member of the Tomahawk family and continues in full-scale production. After launch from the torpedo tube of a submarine, just one of 4 launch platforms, the missile broaches, powered by an expendable rocket motor. Control fins deploy for stability. In seconds, the engine inlet and wings deploy. The spent rocket motor is jettisoned. An efficient turbofan engine takes over, and Tomahawk speeds toward its programmed target. If the assigned target should be an enemy ship, Slickum systematically searches a large area of the sea, locking onto the signature of the target ship, and with precision accuracy, homing in for the kill. Fitted with a conventional or nuclear warhead, Slickum can be assigned a target up to 2,500 kilometers inland. Navigation is inertial, refined with updates from the Terrain Contour Matching System, TERCOM, and has an on-target accuracy within meters. A submunition dispensing variant of Tomahawk is designed to fly against revetted aircraft and similar targets. In this variant, packs of submunitions are ejected from the Universal Payload Bay. The Universal Payload Bay can also be used for other types of submunitions or countermeasures. With submunitions gone, Tomahawk then flies on to attack a final target as an accurate kinetic force projectile. Slickum is readily launched from surface ships. This armored box launcher is on the battleship New Jersey. CGN-9, 36, and 38 class cruisers, plus DD-963 class destroyers like the USS Merrill, are also receiving Tomahawk capability. Another launch configuration is vertical. Here, the missile is stored below decks in an upright position and launched straight up. On CG-47 class cruisers, DD-963 class destroyers, and DDG-51 class guided missile destroyers, each ship is able to carry a larger number of missiles in a limited space, increasing firepower. In submarines, 12 tubes located in the bow of SSN 688 class boats provide the vertical launch capability, in addition to launch from the torpedo tube. Submarines provide Slickum with ideal launch platforms, virtually free from interdiction and adding a new dimension to fast attack boats.
Advances in submarine performance have necessitated corresponding upgrades in anti-submarine warfare torpedoes. Recent strides in Soviet technology present a significant potential threat. This has alerted our government to the need for a heightened defense effort. The Soviet Alpha-class submarine, for example, has been reported by Jane's fighting ships to be the fastest submarine in the world. Consequently, the United States has a great need for an advanced capability torpedo, one that will counter submarine threats with more speed and accuracy than ever before. An improvement over the Mark 48 torpedo, the Mark 48 ADCAP torpedo will run faster, go deeper, and travel farther than any other torpedo used by the United States Navy. This submarine-launched heavyweight torpedo is capable of acoustically homing in on fast-moving targets in a diversity of environments. Its guidance and control subsystem serves as a computerized internal brain, which is able to identify targets. The intricate subsystem directs the torpedo to the target, successfully completing search, homing, and re-attack missions. The digital technology of the ADCAP contributes to the Navy's capability to provide an at-sea deterrent to present and growing future threats.
When the concept of a submarine-launched missile was first proposed in 1955, skeptics said it could never work. But the successful launch of a Polaris test missile from the submarine USS George Washington on 20 July 1960 ushered in the era of the fleet ballistic missile, and the Navy's submarine-based weapon system has stood the test of time. The Navy's first fleet ballistic missile, the Polaris A-1, had a range of 1,200 nautical miles. The Polaris program extended the missile's reach, achieving a range of 2,500 nautical miles with the A-3 missile. Then the Poseidon, or C-3 missile, introduced multiple warheads, each capable of reaching a separate target, significantly enhancing the system's effectiveness. And the Trident development program resulted in a more survivable deterrent, an improved missile with a range of 4,000 nautical miles. And a new submarine, faster, quieter, and most of all, larger, carrying 24 missiles instead of 16. The Trident II or D-5 missiles carried on board the Tennessee-class submarines, the newest and most powerful in the Navy's underwater arsenal, incorporate major advances in missile design and manufacturing. For example, graphite epoxy, an extremely strong yet lightweight material, is used for the casings of the solid propellant rocket motors. This, along with other advancements, allows the Trident II missile to achieve a range greater than the 4,000 nautical mile reach of the Trident I.
Just as the ocean's depths present complex defense situations, ground forces are confronted with unique challenges too. Today's military technology and integrated battle management systems provide the basis for state-of-the-art advances on the frontline battlefields of the 21st century.